Hi everyone, and welcome to a new video on this channel. This time it's about deploying Helm charts with Azure DevOps. It can be about GitOps all the time, right? And you should see this as an introduction to this material. What we'll do is first discuss a little bit what Helm is all about, and then later we'll show an example of how to deploy Helm charts to a Kubernetes cluster using Azure DevOps pipelines. But first of all, what is Helm? Helm is basically a package manager for Kubernetes, similar to how an operating system package manager works. You have packages that are stored somewhere, typically in the cloud or some local private repository, and they're Helm repositories, and they contain the packages, which we call Helm charts. You can use familiar install, upgrade, and delete commands, and of course you can also configure the packages before installation, which is an important feature when you're deploying your applications to Kubernetes and you use multiple environments, for instance. And of course, Helm also has several discovery tools. You can list the installed packages on your cluster and so forth. And of course, the reason why it is used is to make Kubernetes application deployments easier, because typically they are a combination or a bunch of YAML files, right? And you also want to have it highly configurable. Now, Helm today is at version 3, and that's the current version. Version 2 used the server-side component, so something you had to install on your cluster called Tiller, and that component is removed in version 3. Basically, you shouldn't use version 2 anymore and always stick to version 3. That also means that Helm is now merely a client-side component. So you just have to install the Helm executable on your system, on your agent, for example, if you're using something like Azure DevOps, and you can start. Now, sometimes confusing is that the chart API version is version 2. So basically the format of the chart, what you can use inside a chart, that version is version 2. Helm v2 used version 1. You already heard me use the term chart. Now, what is a chart? A chart is merely a folder structure with files in it, just text files. And here you see an example in the charts folder. There's one chart which is called Go template. Now, that Go template folder contains a chart.yaml, which contains, for example, the name of the chart and the version of the chart, and a values.yaml, which is used to submit values during deployment time. So when you install the chart, values can be read from this file and submitted to templates. Now, the actual templates that will receive the values from the values.yaml file are all stored in the templates folder you see there. Now, this is a simple example of a chart that contains just the deployment, an ingress, and a service YAML file. And we'll see later a bit what the format is of these files. Now, of course, it's not very handy to exchange Helm charts or to store them somewhere if they are a folder structure. So, of course, you can package a chart in an archive. The Helm package command can be used for that. So if you have installed the Helm executable on your system, you can just do Helm package and then refer to the folder that contains your chart, and you'll get something like you see here in the slide, the chart name dash the version of the chart and then the TGZ extension. Now, if you want to create your own chart, I won't show this in this video, but if you want to create your own chart, you don't have to start from scratch. There's a command called Helm create, and you give it a chart name, and it will create a folder structure for you that will look a little bit similar to what you see here on the screen. And yeah, by default, that chart will install something like Nginx, but of course you can modify that template the way you want to. Now, what does a template look like? Here you see an example of the service.yaml template. And if you have worked with Kubernetes before, of course, you can see it resembles a typical service resource that you want to create in Kubernetes. But of course, it's a template, so we want to modify what's inside this template with values at install time. Now you don't have to think too much or worry about the includes. I will not explain those, but of course if you see what's there, the include probably has something to do with giving the service a name and also giving the service some labels. What I want to focus on here is the values. You've seen me talk about the values file in the previous slide. Well, here what we will do is we will retrieve the service type from that values file, from the submitted values file. And also a bit lower, we retrieve the service port value from the values file. And here you see an example of the values.yaml file. It's just a regular YAML file. And in the previous slide, I referred to service.type and service.port. And here you see that it's supplied to the YAML file, the values file, with service and then type and port that you see over there, next to some other values that have been defined. Now, of course, it might be that at deployment time, for example, in your pipeline where you run your helm install command, you might want to grab a variable or a secret from your pipeline, for instance, and then use that secret as one of the values you submit to the chart. Well, of course, that can be done because the helm install command can be further configured with a --set parameter. And for example, there I could say --set service.type is load balancer, for instance, and to override the cluster IP setting that you see here in the example. Now you know the basics of what a Helm chart is. The question now is, how do we install such a Helm chart? Well, for example, if you would like to install Nginx Ingress Controller on your cluster, you would simply follow 3 steps. First is that you would add the repo that contains the chart definition. That's a Helm repository. And it's also very easy to create your own Helm repositories, as they are simply a HTTPS URL. Secondly, we would use or run Helm repo update. And when that's done, we can use the Helm install command. So in this case, we are telling Helm should grab the Ingress Nginx chart from the Ingress Nginx repo. Of course, there are all kinds of variations on this theme. For example, you could have your Helm on your file system, your Helm chart on the file system. And then you would do a Helm install and you would refer, for example, to the location of the chart, this set of folders we talked about earlier, on your file system. So many variations are possible. This is just one example of, first of all, adding a repo and then installing the Helm chart directly from the repo. Now, of course, this is a talk about how to install Helm charts with Azure DevOps. So let's take a look at that. Naturally, you can always use bash commands or a bash task, so to speak, to install a Helm chart. If you have the Helm executable installed on the Azure DevOps agent, you can just do so. But of course, Azure DevOps has all sorts of tasks available as well, and there's also a Helm deploy task. And the inputs to the task will specify what the Helm command should do. So basically, this task is just a wrapper around the Helm command. Well, first of all, we have to tell Helm what it needs to do. In this case, we want to install a chart, but as a best practice, you typically will use the command upgrade for this. And you specify with install true to do a fresh installation when it's the first time that you run this command. Now, the Helm chart supports several connection types. To authenticate to your cluster, it supports the ARM connection type, so to just authenticate to your Azure subscription, or you can also have a Kubernetes connection type, which would work with any sort of Kubernetes cluster, not just a cluster that's running on Azure, for instance. In this case, we're using the ARM connection type, so this is for an AKS cluster. In this case, we also see that we don't install the chart from a repo. Instead, we are using a file path and we point to the path with a chart path input. In this case, we also use a packaged chart. I talked about that earlier. You just package up the set of files and folders of the chart in a DGZ file. What you don't see here is overriding values with --set. That is of course possible, but we just don't do that here. That also means that the standard values YAML could be used here. Now you'll often come across the question, where do we store the Helm charts? So I talked about, for example, a Helm repository earlier, which is just an HTTPS link, just a web server that you can use for that. But it's also possible to store these Helm charts in a OCI compliant registry. OCI is the Open Container Initiative, and ACR, which is Azure Container Registry, is such an OCI compliant registry. And that means we can store the Helm charts directly in Azure in something like ACR. Now what you can do there is use the Helm registry command to log in to ACR. That's fully supported. And then you can use the Helm chart push command to push the TJZ file to the ACR. There's also a command, by the way, in the Azure CLI, ACR Helm, but that is deprecated. Now, the issue here is still that this OCI support in Helm is experimental, so you have to do something to enable this functionality. And also note that storing Helm charts in Azure Container Registry is a preview feature as well. So it's up to you, of course, if you want to use this or not. Typically at customers, we refrain from using it today, but, and you'll see that in the example, it is something that is working, and you'll see how it works in a moment. Now the question, of course, is why do you use this? Well, first of all, with most people that I work with, it's something that they're very used to, and it's somewhat of a default approach to creating applications for Kubernetes and packaging applications for Kubernetes. They like it because you can indeed create versioned application packages. You can then use the similar OS-like semantics to install, upgrade, uninstall these packages. You want to also store these packages in an artifact repository, and maybe those have also some kind of scanning technique, security checks, and so forth. And of course, naturally, in most cases, you want a way to easily supply configuration parameters. And that's typically across multiple environments, like let's say a QA environment and a production environment. And you might want to change things up a bit depending on the environment that you deploy to. You'll see in a moment in the example that is also what we do in the pipeline. All right. I think it's time for a demo now. But before we start, a little bit of background on the demo. What you won't see in this demonstration is the whole cycle of developing the application and deploying to a test or a development environment. So you should just think that that is something which is also part of the configuration, but we're not discussing that. What I'm going to discuss is that when you have your Git repo with your code, your Docker file, and the Helm chart all together in this case, when a commit to main happens, we want to run indeed ACI pipeline first. So that one is kept deliberately simple. We do a Docker build, a Docker push. That means we build our Docker image and then we push it to Azure Container Registry. And then we'll use the Helm package command and Helm push to also push the chart to ACR. Again, be aware that this is preview functionality, right? Now, from the moment that we have the Docker image and the Helm package pushed, we will save the versions of these into a file called variables.json, and we'll drop that as an artifact. Our CD pipeline will be triggered on that artifact and then start the actual deployment, first to a Q&A namespace on a cluster. It will then wait for approval, and then we'll deploy to a production namespace on the same cluster in this case. That's just an example. This could be two different clusters as well. In this case, it's the same cluster. Let's see how this works. Let's first look at the source files a bit. Just know that our Docker file here results in a relatively small image because we're using Go as an example here. In the first stage of the build, we're doing a little bit of testing with Go test, as you can see here. Then we build the static executable. And then in our actual image, which is based on the Scratch container, we copy the app that we compiled here with the copy step, and then as the entry point we have our app running. Note as well that we have configured a user called my app in the previous step. We've also copied the etc passwd file here, and this user is user 10,000, and we will also refer to that basically in our security context in our container later. So that's actually the Docker file that we use to build our container, and we'll later push that container to container registry. Now our chart is also in the same repo here, and the chart.go template that we've seen earlier, it contains our chart.yaml. And as I discussed, this one has a version, so the chart has a version, but you can also notify the Helm chart of the application version that you want to use. In my case, the version is 0.0.2. Of course, you choose how you do your versioning here. In the values YAML, you'll find all the values I'd like to use to configure the application. For example, we've already seen that we have the service configuration with a service of type cluster IP and port 80. But as you'll also see here, I have things like defined resource limits and requests, but also, for example, a security context. And of course, I want to use the values defined in this values YAML in my templates. The service.yaml you have seen already in the slides. That's the same one. So we grab the service type and the service port. We grab this from values YAML. And if you check in deployment YAML, you'll see that we have some templating going on here. For example, to also pick up the, for instance, the security context from our values YAML file, but also the resources that were defined in the values YAML file. Maybe also good to know is the image that we will use, the container image when we deploy to Kubernetes. Where does he get the container image and the container tag? Well, the container image, the repository where it's at, is in values image.repository. Now that one, if you have looked closely in my values file, refers to an image in the GitHub container registry. I will override that later with a repository that's in ACR. Then as a tag, I can either set the tag myself in the values.yaml file or as an override, or I actually use the app version that comes from chart.yaml. So if I don't specify, you can see that here, if we don't specify this tag over here, when this is empty, by default, you will take the app version as defined in your chart.yaml. So that's 0.0.2. That's how we actually refer to the image that we finally, of course, want to deploy to our running Kubernetes cluster. Let's now take a look at the CI pipeline. As you can see here, the pipeline is defined in YAML. That's highly recommended. It's really not a good practice that you use the GUI for this. So the pipeline here is ci.yaml. I'm not going to go in all the details and explain what all these things do. That's in the documentation. But I mainly will say here that you can see the trigger is just based on main in this example with some excludes. We're using the Microsoft Ubuntu agents to run the pipeline. And our variables and steps are defined in sub-templates or templates. They can be found in the common folder. I have some variables here like what's my registry server, what's the Helm version, what's the project name, and so forth. And then the actual work is done in the CI steps.yaml. These are the steps that I'm doing in the CI phase. And remember, this phase is basically to build my container, which includes also testing the source code and so on, because that's part of the container build. And then also push or build and push the chart. And we do that both to ACR. So remember in this example, we push the container image to Azure Container Registry, and we push the chart package to Azure Container Registry as well. Now, what do we do here? Well, very simply, we'll first set our image tag to the git commit SHA. We then build our Docker image where we include the full registry name to ACR the image name, which is Go template, and the image tag, which is in this case the git commit SHA. I've also included for reference a SNCC security scan, although it won't be able to scan much because this image is based on the Scratch image, so there's not much to do. Then we simply log in to our Azure Container Registry, and I'm using the admin credentials for that. And then we simply push our image, which is rather small. It's not a big image. I think it's something like 30 megabytes or something. We push it to Azure Container Registry. Now, I realize that there are Azure DevOps tasks for this. I decided not to use them and use the, let's say, bash commands. So it's more clear what you actually have to do, because the Azure DevOps tasks, yeah, they hide this a bit. They're a wrapper around these commands. Now, when that is done, we have done our Docker push. We can start with the Helm steps. But of course, we first have to install Helm, and I want to install Helm based on the version I set in my CI vars.yaml, right? Then I just do a simple Helm lint to check the format of my chart to see if it's any good. If there are errors, the pipeline will halt and I will have to correct them first. And then what we do is we run Helm package. So we basically grab the chart here in Go template and we run Helm package on that. So the result is a TGZ file, right? A Helm chart package. Now, as I said earlier, there is a way to push this Helm package to ACR. But I also discussed that this is experimental. So for this to work, you have to set Helm experimental OCI to 1. And then, and only then, can you use Helm registry login, similarly to how you use Docker login, to log in with Helm to ACR. Then we can push the chart to ACR. Now, to do so, we need to first save the chart locally in, let's say, a local chart repo, a bit similar to how you store local Docker images. It's very similar. So with Helm chart save, with that command, you can basically tell Helm, hey, you need to grab this Go template on the file system here, and you save it locally with the full name that you would use to push it to ACR. Now, when I push to ACR, I also want to have the version of the chart. Problem is, I didn't specify the version of the chart anywhere. So the output of Helm chart save contains a version field, and with some grep and awk, we grab that version field, which in my case is 0.01, and we save it in the chart version variable. Now we can use this command here, Helm chart push, to basically push the Helm package to ACR. That's done. When this step is finished, what we do here, and I won't discuss the entire command, we then create a variables.json file as an artifact, and the artifact contains the chart version 0.0.1 and the image version, which is the git commit SHA. And of course, we save or we publish this file, this JSON file, as a build artifact. Our pipeline pushed an image and a Helm chart to the repository. So let's take a look where they are. My image was pushed to the Go template repository. And you see, of course, here several pushes, and these are the git commit SHAs that we use as a tag. If we click on that, we can indeed see our manifest a bit, and there are only a couple of layers. It's a relatively small image and simple image as well. If you go back to our repositories, we also see this Helm/Go template here. Now, if we click on that one, you'll see that I have a 0.0.1. Yeah, in my pipeline, of course, I keep on using the same version, so I'm not like incrementing that version or something like that. It's up to the maintainer to, when he or she modifies the Helm chart and thinks it warrants a new version, that the version should be changed in chart.yaml, and then you will see that this appears as a new tag here in the list. So my 0.0.1 here is basically just this thing with one layer, which is my Helm package, which is also very small. So you can see here we have our Helm chart, the package of that stored in ACR, and we also have our Docker image stored in ACR. Great, so now we have our two artifacts in ACR. We have the Docker image and we have the Helm chart, or the package of the Helm chart. Now, of course, we need to do the actual deployment of the application to Kubernetes. Now, we want to trigger our deployment based on the variables.json that was dropped as an artifact during a CI, and we do that here with resources. So that's how this one gets triggered. And then, of course, when we have that one, we can run our different steps. Now, we want to deploy to both QA and to production. Now, in this case, it of course pays off that we have our steps in a template, because for both QA and for production, we want to use the same CD steps. Same steps will be reused, but we specify different variables for all these steps. So the first job that we'll do is we'll deploy to QA. So we have a stage for this, right? Stage, and our stage is called QA, and then our stage can have several jobs. Now in this case, it's just one job, and this job is using an environment, right? This is a dynamically created environment, which we call QA project name. So for QA, we have an environment, I'll show you that later, and then we'll run our steps for QA and we will tie it to this environment. And as you can see here, now our Helm parameters will be interesting. Why? Because we basically are saying here, first of all, the namespace will be different, but also the number of replicas I want to deploy in QA is different from the ones I want to run in production. I'm not saying you should do this. I'm just saying we're using this here as an example of providing different parameters at install time per environment. So let's look a bit at the CD steps in common, CD steps. What you'll see here is that it is fairly simple. What we'll have to do is we'll have to install to our Kubernetes cluster. So we need to also authenticate to the Kubernetes cluster. So what I'm using here is, first of all, that I am logging in to Azure with a service principal. Again, I could have used an Azure DevOps connection for this, but I'm not doing that here. So I'm showing the manual steps in the pipeline. There are alternatives to doing this, right? And maybe that's even cleaner to use the service connection, but in this case, I'm using the Azure CLI commands from Bash, so you clearly can see what you need to do. So in this case, I'm doing a login based on a service principal I created before in Azure AD. And this service principal should, of course, at least have the Azure Kubernetes Server cluster user role. Now, in my case, that service principal has the Azure Kubernetes Server cluster admin role. That means it is allowed to pull the kubeconfig with AZ-AKS get credentials and use the --admin. Now, am I saying that this is a best practice or a good thing to do? No, I'm just showing that this is one of the approaches that you can follow. Normally what we do is we are giving just the cluster user role. We give that service principal here with the ID that is referenced. We give that a role within Kubernetes, only the thing that it needs to do, like deployments to certain namespaces or all namespaces, it depends on you. And then when we run AZ-AKS get credentials, we don't use --admin. Now be aware that that will be an issue if you have an Azure Active Directory integrated cluster. So in that case, you should use kubelogin as well to convert your kubeconfig so that it contains the actual token from AAD that you use to authenticate to Kubernetes. It's all a little bit complicated, but that's actually has nothing to do with what we're actually trying here. That is, we want to deploy a Helm chart. But of course, to deploy a Helm chart, I first need to make sure I'm authenticated to Kubernetes using the kubectl command. So great, we are authenticated, hopefully, right? And then we need to install our chart. Now, I don't have the chart in this case because I even didn't do a checkout. So I don't even have the source files that contain the Helm chart. So I need to grab the Helm chart from somewhere. That's not a problem because, again, by turning on Helm Experimental OCI 1, I can log in to the ACR with Helm Registry login. I can then grab the chart version and the image version from our build artifact, right? That's coming from our CI step. I just echo these out here, echo chart version, echo image version. And now I know the chart version, I can pull the chart from ACR using indeed the ACR name /Helm, which is in this case hard-coded, the project name, which is Go template, and then the chart version, which is coming from variables.json, and it's 0.0.1. Now, in order to install this chart properly, we have to export the chart. So I export it to the file system in this case, and then I'm running the Helm install. But as I said, best practice is to do an upgrade. I'm running the Helm upgrade command over here. And here you do see an example of overriding what's in the values.yaml with the --set parameter. So I want to set the image, the container image I'm deploying here. Yeah, I want to set that to my ACR server name and the Go template project name. And the image tag in this case, I don't want the pipeline to take it from the chart. I want to override the image tag by using the git commit SHA instead. Often you see that this happens, that you don't always update the version of the application inside the Helm chart. And to also make sure that I have different amounts of replicas depending on the environment, in this case, I took the replicas environment or the variable I set for my environment, and I override the replica count that's used in my template, in my Helm template, with that value. So for QA, that will be 1, and for production, that will be 2. And that's it. Now the Helm chart is installed on the AKS cluster, or should be. Okay, so now you've seen the CI pipeline and the CD pipeline, but of course you've just seen the YAML files. They don't just magically appear as pipelines in your Azure DevOps environment. You of course have to create a pipeline here, and then you can refer to the CI YAML or CD YAML in my case, that's in the source control repo or in the Git repo. So I already did that, and that's why you see the CI and CD pipelines over here. You have also seen me reference environments in the CD pipeline. Those environments, they will end up here in environments, of course. And there you see the QA and the prod environment. And I also attached the name of, in this case, the project as well. If I click, for example, on QA, I can see everything that happened in QA. And of course, the same thing for production. Now, an additional thing with these environments is, of course, also that you could create them yourself in advance and set all kinds of properties on these environments. In that case, you would refer to an environment, an existing environment from within your within your pipeline definition. Now, these environments have some interesting properties. For example, the production environment, there you'll see that I have a approval and check also configured. There's an approval here, all approvers must approve, and that is, in my case, that's just my own account that must approve the how we proceed, or if we proceed to a production environment after the deployment to QA was done. Let's take a look what that looks like. Okay, so I triggered the pipeline again, the CI pipeline. And of course, yeah, that then progressed into the first stage, the QA stage from the CD pipeline. And what you'll see here is the CD pipeline with the latest run. And here you see there are 2 stages. And of course, here QA was success. This one, of course, here is waiting. And that's because we have this approval step configured. So if I click on the actual run and I go to below a bit, you'll see here indeed stages. This one is waiting and 0 out of 1 checks passed. I can just click on that and say I'm going to approve this step. And now this stage, the production stage, can run. Let it run and then take a look at Kubernetes to see if these two stages were successfully run and deployed my application. So here we have the cluster that we deploy to. You can see that in the Kubernetes resources view in the namespaces that we have this Go template prod namespace and the Go template QA namespace. And remember, for each environment, for each stage, we supplied a different namespace name. Now, when I'm looking at the workloads, there's nothing that special to be seen there, but what you'll see is, of course, that if I'm going to my Go template QA namespace, I have 1 out of 1 ready. If I go to my Go template prod namespace, I have 2 out of 2 ready. Because, of course, I specified 2 replicas for production and only 1 for QA. All right, we've come to the end of this rather long video, but the main things to take away here is, first of all, of course, that Helm is regularly used to deploy applications to Kubernetes. We've looked a bit at how Helm works, and then we have shown an example CI and CD pipeline in Azure DevOps, where we build a Docker image and push it to ACR, but also we package a Helm chart and push it to ACR. And then we use those two artifacts to do our deployment to QA and to our production environment, again, just using Helm. Be aware, and I just have to stress this, that of course this is all experimental. So the Helm packaging, the Helm pushing and storing Helm packages in the Azure Container Registry is either experimental or in preview. I hope you like this and see you next time. Bye bye.